Welcome everyone to another math video. So today's lesson we'll be talking about trigonometric ratios. So if you're excited about learning about this, then keep watching. So first let's talk about what trig ratios are. So a trigonometric ratio or a trig ratio is the ratio of two sides in a right angled triangle. So it has to do with right angled triangle. So the sides of the right angled triangle are determined by the angle being considered. So let's go. So here we have two right angled triangles. So we're just going to go ahead and identify the different sides. So from the previous videos, you were exposed to one of the sides. So the hypotenuse, so we know that the longest side of a right angled triangle is called the hypotenuse, right there, and it's always opposite to the right angle, or the 90-degree angle. So the next side that we have is our opposite side. So the side opposite to our angle, or a given angle, is called the opposite side. And the third side is the side next to the angle, and it's called the adjacent side. So it's the side that is adjacent to the given angle. So hypotenuse is the longest side. The side opposite to the given angle is called the opposite side, and the side that is immediately beside or next to the given angle is called the adjacent side. So go ahead and identify the sides of this right angle triangle. So we see that the given angle is at the top right here. So which one of the sides would be the hypotenuse, the opposite, and the adjacent? So the hypotenuse would be this one right here, the longest side, and the one that is opposite to the 90-degree angle. Then we know that the opposite side would be the one that is opposite to the given angle, and the one next to the given angle is the adjacent. So these are the three sides of the name of the three sides of a right angle triangle, and it's very important that you know how to identify the three sides. So the ratios are given using, so based on the angle and the sides that are involved, that is how you would calculate the trig ratio. So we are focusing on the three main trig functions, and these are, first one is sine, but for short it is sin. So sine x, where x is the given angle. So sine theta or sine angle is equal to opposite over hypotenuse. So the opposite side over the hypotenuse side. So the next trig function is cosine. So let me just write the name. So it's cosine, and for short we normally write cos. So cos theta is equal to the adjacent side over the hypotenuse. And the final trig function is tangent. And for short, we say tan. So tan theta is equal to opposite over adjacent. So a useful memory aid for remembering these three ratios are SOHCAHTOA. So sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So let's go ahead and start working some problems. For the triangle below, we're asked to find cos theta, sine theta, and tan theta. We know that cos theta is equal to adjacent over hypotenuse. So let's identify the sides. So we know that the longest side is the hypotenuse. We know that the side that is next to the given angle or theta is the adjacent side. And we know that the side that is opposite to the angle is the opposite side. So now that we have identified the three sides, we can go ahead and find what is cos theta. So cos theta is equal to the adjacent side. So the adjacent side is 4. And the hypotenuse is 5, therefore cos theta is equal to 4 over 5. Let's move on to B. So we're asked to find sine theta. And we know that sine is opposite over hypotenuse. And the opposite side is 3. Hypotenuse is 5. Therefore, sine theta is equal to 3 over 5. So we're not given what the value of theta is, what the angle is. So we cannot work any further. Let's do the final one. So tan theta, and that is equal to opposite over adjacent. So opposite is 3, and adjacent is 4. Therefore, tan theta is equal to 3 over 4. So there we have just found what is cos, sine, and tan theta. So here's our second problem. We're just going to go ahead and label this side. So we see that this is the longest side. It is opposite to our 90-degree angle. So this is our hypotenuse. So our hypotenuse is 5 meters. We're given the angle. So our angle is 40 degrees. Side opposite to the 40-degree angle would be our opposite side. And this side right here would be our adjacent side. All right, so let's go ahead and calculate BD. So BD in this case is the opposite side based on the sides that we are dealing with. So we know, so we want to find the opposite side and we have the hypotenuse. So we're working with opposite and hypotenuse, therefore it has to be sine. So we have to use sine theta to give us opposite over hypotenuse. And let's just substitute our values. So sine 40 is equal to, we don't know what the opposite side is. So let's just write BD. So BD over 5. So I want to get BD, which is our opposite side, by itself on one side of the equation. So we need to get rid of this 5. And to get rid of that, we can just multiply both sides by 5. And when we do that, we'll have BD is equal to 5 times sine 40. Plug this into your scientific calculator and you will get a very long number. So we're going to round it to 2 decimal places. So our answer, so BD would be 3.21 meters to 2 decimal places. So we just found what is BD. So we're going to go to part B, and it asks us to find DC. So seeing that we just found the opposite side and we have the hypotenuse, we could have used the Pythagoras theorem, but we're going to go ahead and use trig ratio. So if let's say that we did not find the opposite side and we only have the hypotenuse, and want to find the adjacent, the trig ratio that works with adjacent and hypotenuse would be cos. So we would have to use cos theta. Cos theta is equal to adjacent over hypotenuse. So let's go ahead and substitute. So cos 40, theta is 40, is equal to adjacent. We don't know what the adjacent sign is. We're just going to use DC over the hypotenuse, which is 5. And again, we want to get DC by itself. So we multiply both sides by 5. And we're just going to swap the terms. So we're going to put the DC on the left hand side. So DC is equal to 5 times cos 40. And when we put that into our calculator and round it to 2 decimal places, we'll get to 3.83 meters. So let's go to our C. So it says that we should prove that the area in meters square of the triangle BDC is 12.5 sine 40 cos 40. So looking at this, some person will say, oh my God, this is hard, but it's rather simple. We just found out what BD is and also what DC is. All you will be doing is substituting these two things into the formula to find the area of a triangle. So in order to find the area of a triangle, it's equal to half times base times height. So let's go ahead and substitute. So half times, so the base in this case would be the adjacent side, DC. And we know that to find DC, it is just 5 times cos 40. and we multiply that by the height, and in this case the height would be BD, which is the opposite side. And to find the opposite side BD, it was 5 times sine 40. So all we have to do now is just do some simplifying. So we see that we can, so we're multiplying, so we're just going to rearrange these and multiply the constants. So half times the 5 over 1 times the 5 over 1 times cos 40 times sine 40. And when we multiply these three, we'd get, so 1 times 5 gives us 25 over 2 times cos 40 times sine 40. And we can simplify this. So 2 into 25 will give us 12.5. And we can just write it as we see there. So it's multiplication. We know that multiplication is commutative. So it doesn't matter if the sine comes first or the cos comes first, it will still give you the same answer. So there we go. We have just proved that the area in meters square of the triangle would be 12.5 times sine 40 times cos 40. And just by solving this, you'll get your 2 marks. So let's move to our next problem. So we're given a right angled triangle. We're just going to go ahead and identify the sides of this right angled triangle. So the x would be our hypotenuse. This is our given angle. Therefore, the 17 is our opposite side, and this is our adjacent side. So based on the sides that we are dealing with, that will tell us which one of the trig ratios we will need to use. So we want to find the hypotenuse, and we have the opposite side, and we know that the trig ratio that deals with opposite and hypotenuse is sine. Sine theta is equal to opposite over hypotenuse. We're going to substitute our values. So sine 38 is equal to 17 over x, and we're just going to do some transposition. So we want to get x by itself, so we need to get it out of the denominator, so multiply both sides by x. So x times sine 38 is equal to 17. We want to get x by itself, so to get x by itself we need to divide both sides by the sine 38. Therefore, x is equal to 17 divided by sine 38. All you're doing is plugging this into your calculator. When we plug this into our calculator, we'll get x being equal to 27.61. We're not given any units, so that's our final answer right here. So that is our final answer right there. So this is the first part of our 2-part video. So we have discovered the trig ratios. So sine equal to opposite over hypotenuse, cos equal to adjacent over hypotenuse, and tan equal to opposite over adjacent. And we use those trig ratios to find a missing side of a right angled triangle. So the next video that is coming up, we will be using the trig ratios to find the missing angle. So stay tuned for that.